Multiplication and division of significant figures. In multiplication and division of significant figures, the number of significant figures in the final product, if it is multiplication, or the number of significant figures in the final quotient in case of division, is determined by the original numbers. This or this or this and this, they are the original numbers. So the number of significant figures in the final product or quotient is determined by the number of the the original number that has the smallest number of significant figures. Now, what does this mean? Let us take this example here, multiply 1.5 grams and 8.012 grams. So when we multiply these two, sorry, okay, when we multiply these two, 1.5 grams into 8.012 grams, we get final answer as, you can calculate it later and then see the final answer is 12.018 gram. Okay. So here, before rounding off the final answer to the number of significant figures, you have to check how many significant figures are there in the original number. In this original number, 1 and 5, two significant figures are there, right? And in this case, 1, 2, 3, 4, four significant figures are there. So the least number of significant figures that are present in both the numbers is 2. So our final answer has to be rounded off to the two significant figures, means up to 12. So this answer can be 12.018 grams, right? Means up to here you have to round off. Okay, this part you are, sorry, this part you are going to take. But before dropping all these digits, again you have to check whether this particular digit is less than 5 or equal to 5 or greater than 5. If it is greater than 5 or equal to 5, you will just add up one digit to the preceding digit. So here 0 is present, here 1 and 8 are present. So if suppose if you want to drop off 8, then you will add one digit to here. So it becomes 12.02. But again 2 is less than 5, so you need not add up anything. So it remains 0 here. So simply you can drop off all these three digits. So your final answer will be 12 grams. Okay, this will be the final answer. Now, in the case of division, it's the same rule for the division also. When you divide 11.2642 grams with 2.13 grams, which will be equal to, you can calculate it later, but I'm just writing the answer over here, 5.3133018. See how many numbers are there, but we have to round off. So before rounding off, let us check how many significant figures are there in the original numbers. In this one, 1, 2, 3, 4, 5, 6. 6 significant figures are there. In another number, 2.13. So how many significant figures are there? 3. So how many least number of significant figures are there in the original number? 3. So our final answer needs to be rounded off up to 3 significant figures, means up to here. So your answer will be, and you have to check before dropping off, here it is 3, which is less than 5. So you need not add up any, you need not add up 1 to the preceding digit. So here also 3, so you can simply drop off all these things. So your final answer will be 5.31 grams. Now let us see this example. If A into B is equal to C and C into D is equal to E, where A is equal to 2.66 grams, B is equal to 7.40 grams, and D is equal to 2.11 grams. So in such cases, okay, I will just show two methods and we will discuss which is the right method for this. So first A into B, we know A is 2.66 grams. So 2.66 grams into B is how much? 7.40 grams. 7.40 grams. So this one will be equal to 19.684 grams. So as per like, how we have studied over here, in this case, there are 3 significant figures. And in this number, there are 3 significant figures. So your final answer here has to be rounded off to 3 significant figures, means up to here. But here 8 is present, so obviously you're going to add 1 digit here, so it will be 19.7. Okay. Now this 19.7 is C, which is nothing but C, right? A into B, when you add, when you multiply, you will get C. And this is C on multiplying. The C is 19.7 grams on multiplying with D, which is 2.11 grams. How much you will get? 41.567. So here in this case, 3 significant figures are there. And in this case also 3 significant figures are there. So you have to round off your final answer to the 3 significant figures, means up to here. But 6 is present. So obviously you have to add 1 to 5. Then it will become 41.6 grams. Okay. Now just this is one of the methods. Now let us do other method. I will show some other method also, and then we will compare both which one is correct. Okay. So similarly here also 9.66 grams, which is A, into B, which is 7.40 grams. Then we multiply these two, we will get 19.684 grams. Okay. But here I'm not rounding off, but instead I'm taking this number directly as a C without rounding off. So 19.684 grams, which is C, into D. D is 2.11 grams. Now this one, after we multiply, we will get 41.5332. Now, in all these cases, here 3 significant figures. In this case, original numbers, if we see, here 3, here also 3 significant figures are there. In this case, 1, 2, 3, 4, 5 significant figures are there. And again, in this case, 3 significant figures are there. So in all the original numbers, 3 significant figures are there. So final answer has to be rounded off to 3 significant figures, means up to here. And whatever the digit we are going to drop off, there 3 is present, which is less than 5. So we are not going to add up anything over here. So your answer will be 41.5 grams. Now check in both the methods. In this method, you got 41.6 grams and here you got 41.5 grams. So we have to be very precise and accurate whenever we are dealing in chemistry. So which one is the right method? So whenever we have multi-step process like this, whether it is multiplication or division, you should not round off the numbers in each step. You are not supposed to round off, but you have to carry on the complete number to the next step, and only at the final step you are going to do this rounding off. So this method is the right method. So this is the right answer, 41.5 grams, whereas this is the wrong one. Okay. So we have, wherever this multi-step process is there, in case of multiplication and division, we are supposed to not round off at each step, but instead you have to round off only at the final step. Then only you will get the correct answer. Okay, now let us see this fourth one. A 2 rupee coin has a mass of 2.5 grams. If we have 3 such coins, the total mass is dash. So here we know, like, it is a very simple sum. The mass of the coin is what? 2.5 grams. And how many such coins are there? 3 coins are there. So obviously we know, we write 3 into 2.5 grams, which is equal to 7.5 grams. As per this rounding of the significant figures, you can immediately say here only 1 significant figure is there, whereas in this case 2 significant figures are there. So we have to round off the final answer to 1 significant figure, which will result in 8 grams. But in this case, this is wrong. Why? Because here, whatever 3 we are talking about, 3 is an exact number. So whenever we talk about exact number, we have to, I'm like exact numbers will have infinite number of significant figures. So wherever the exact number can be considered to have infinite number of significant figures, we are not supposed to limit the number of significant figures in the calculated result. So this is the calculated result. So in such cases, wherever this exact numbers we are considering, we are not supposed to round off based on that one, because it has infinite number of significant figures. So in that case, this is wrong. This 7.5 grams is the right answer. Okay, we are not limiting the rounding of the significant figures whenever we are dealing with the exact numbers in such problems, in such cases.